Functions. A relation is a rule which associates the elements of two sets. A linear function of the form f of x equal to ax plus b, where x is a member of real number systems and a and b are constants, is called a linear function. Examples: given that f of x is equal to 2x minus 1, find f of 3. So f of x equal to 2x minus 1. F of 3 is equal to, where there's x, replace a 3. 2 times 3 will give us a 6. 6 minus 1 will give us a 5. Given that f of x is equal to 5x minus 3, find f of negative 3. F of x is equal to 5x minus 3. F of negative 3, where there's x, will replace a negative 3. 5 times negative 3 will give us a negative 15. Negative 15 minus 3 will give us a negative 18. A relation from set A to set B is given as x maps onto 4 minus x. Complete the arrow diagram below. So the values in A are representing x and the values in B are representing y. What we are going to do is to replace a 2 where there's x there, and we'll replace a 5 where there's x. 4 minus 2 will give us a 2. 4 minus 5 will give us a negative 1. So our arrow diagram will look like that. We'll replace a 2 and a negative 1. Given the following set of ordered pairs, 10, 5, 8, 4, 6, 3, 4, 2, and 2, 1, find the function representing this mapping. We are going to start. The equation of a straight line is y equal to mx plus c, where m is the gradient given by m equal to y2 minus y1 divided by x2 minus x1. We'll call this x1, we'll call that y1. We'll call that x2, we'll call that y2, and replace. Subtract 4 minus 5, you get a negative 1. 8 minus 10 will give us a negative 2, which is the same as a half. So our gradient is half. Then we'll pick that point, 10, 5, and replace in the equation to solve for c, which is the y-intercept. Since our gradient is half, we'll put our half. Where there's y, we'll replace a 5. Where there's x, we'll replace a 10. 2 into 2, 1. 2 into 10, 5. We'll transpose the 5, it will become a negative. 5 minus 5 will give us a 0. Our c equal to 0, so we'll replace. Where there's that m, we'll replace that half. Where there's c, we'll replace a 0. Therefore, our equation is y equal to half x. Find the value of x when y equal to negative 5. Where there's y, we'll replace a negative 5 and then we'll cross multiply. Negative 5 times 2 will give us a negative 10. Our x will be equal to negative 10. The set of ordered pairs below show the corresponding values of x and y. Those are the corresponding values. Find the function that describes the relation between x and y. We'll solve this question like the way we solved the previous one. Our 4 will be our y2, our 3 will be our y1. Our x will be our 2 will be our x2, and our 1 will be our x1, and then we'll substitute. So the question is saying, find the function that describes the relation between x and y. Find the value of t. So we'll start. The equation of a straight line is y equal to mx plus c, where m is the gradient given by m equal to y2 minus y1 divided by x2 minus x1 we'll replace. 4 minus 3 will give us a 1. 2 minus 1 will give us a 1. Our gradient is a 1. Then we'll pick the point 2, 4 and replace in the equation y equal to mx plus c to solve for c. Where there's m, we'll replace the 1. Like that. So we'll say 4 equal to 1 times 2 plus c. Transpose the 2, it will become a negative. 4 minus 2 will give us a 2. Our c equal to 2. Therefore, our equation is y equal to, where there's the gradient m, we'll replace that 1. And where there's c, we'll replace our 2. Therefore, our y equal to 1x plus 2. Find the value of t. The function is y equal to 1x plus 2. When y equal to 7, this is the point t, 7. Y is 7. Where there's y, we'll replace a 7. So we are going to say 7 plus, where there's the x, we'll replace our t. 7 equal to t plus 2. We'll transpose the 2, it will become a negative. We'll say t equal to 7 minus 2. Therefore, our t is equal to 5. As simple as that.